like to welcome you all for the okay. So welcome you all for the revision series by Saranda and Gearhouse. So today we will covering Maths 1 for this. So let me start with the first question. So in this week, the most focus will be in quiz 2, the most focus will be from week 5 to 8. Okay. So in week 5, we have learned about one function, the composite functions, or logarithmic. In 6 we have learned logarithmic functions, right? Or let me just check it. So in week 5 we have composite function, exponential functions. In week 6 we have logarithmic functions, right? I have shared the link for the master. Logarithmic functions. In week 7 we have limits. In week 8 we have continuity and differentiability. Continuity and differentiability or differentiation. Okay. So this is the main and the most weightage will be from this week only. Most of the problems and some of the concepts like quadratic equation you can expect the slope of the line or or means some of the concept of the week 1 to 4 will gonna use but not extensive use. Okay, not more extensive use. So no need to worry about these things. We will cover it all. If you have just it will be just a you can go through once in the revision series or PYQ or any 1 to 4 we have in YouTube. We have 1 to 4 revision sessions. So just go through that if you have forgotten everything. Otherwise, it would be fine. So today I will gonna start with the questions and followed by I will explain all the concepts that are required to solve that problems and I have taken most frequent problems. Okay, so this session is for maths one. I should. So yeah, this is the first problem we have. Okay, so this problem says that considered of two functions. So we have two functions, right? F of x and g of x, right? Fx and gx, and hx be a function defined as f of g of x. So you can see this is from composite function. This is composite function, and and you have to find the values of maximum, minimum, and what. So consider these two functions. So you have to find the maxima and minima. So for g of x, it is a quadratic function. You know how to find the maxima of the quadratic function. So the question says that this is the follow-up question. This is the first question. This is the second question. The question says that find the maximum value of gx. That means, and gx is a quadratic function that is minus x square plus 4x plus 77. So how to find the maximum value of a quadratic function?
At vertex.
The vertex.
Yeah, at vertex.
Using the
You
formula for
already know.
vertex.
Here A is
Minus
negative,
b by
right?
2a.
Okay. Here A is negative. So if A is negative, what will be the? It will be like this, right? If A is negative,
Vertex.
so the we can find the maximum value only. So the maximum value at vertex. So what is the formula for the vertex? X equal to
Minus
minus
b
b
by
Minus
by
minus
b
b
by
by
2a
2a.
2a.
comes to 2.
So just find the maximum value. X equal to find the
Yeah,
maximum value of x. X equal to what? Minus b minus 4 upon 2 into minus 1. That is equal to 2.
2.
So the maximum value will occur at x equal to so. And then you have to, the question is asking about, you have to find the maximum value of gx. So, so maximum value of gx will be at x equal to 2. So tell me the value.
81.
81, 81.
So the answer
81.
is 81. Okay, 81 is the correct answer. Understood? Anybody having doubt in this?
This
No,
is
sir.
from week 3 concept, na sir?
Yes, this is from week 3 concepts. So there are some concepts which that gonna use. I've already told you the quadratic and the slope part we're gonna use. Okay. So so this is from week 3, and now you have to find h of hx. So hx is defined as f of g of x. Now this concept is from week 5, composite function. Okay. So now tell me what will be the maximum value of hx. So let's find f of g of x. First of all, f of g of x we have to find. So f of g of
Sir,
x is what? Yes.
in G of 2 you have written minus 4, but it's plus 4.
Sorry.
In G of 2, while finding maximum value,
Yeah, while finding the maximum value,
you wrote minus 4, but it's plus 4 now, sir.
here it is minus x square, right? So what will be the value of minus x square is 4, so should be minus 4 here, right?
Sir, the 2 square, sir. Then, if while we are doing the square term, if we convert into 4, no, sir, then how come?
No, no, no. It's outside. It is not. It is like that. See. Okay, it is outside. Not. It is not like that. Minus x whole square.
Okay,
The
sir.
minus is at outside. So that's why. Okay. So let's find f of g of x. That should be equal to gx. What is the value of gx? Minus x square plus 4x plus 77. And then fx will be fx equal to log of 2, log of 2, log of 3, and minus x square plus 4x plus 77, right? This is the f of g of x. Are you getting it?
Yes, sir.
Now we want to find the value. What will be the maximum value of x at hx? So the max of hx will be what? So have you remember the graph of a logarithm function? If a is greater than 0, a is greater than 0. Do you remember? This is the graph of a logarithmic function, right? So
Yes,
whenever
sir.
the x
Yes, sir.
increases, whenever the x increases, the value of fx is also increasing, right? Whenever the value of x is increasing, the value of fx is also increasing. So if someone asks you to find the maximum value of this, what will be the maximum value? The value of log to the base
Log.
x. This is the graph of this. A log to the base x. Log to the base a x. So this is the graph of this. So whenever the value of x is increasing, so for that we want to find the maximum value of this. If the maximum value of this will be the maximum value of hx, because hx is completely dependent on this function, right? Any doubt?
No, sir.
So
No, sir.
okay, so for that we want to find the maximum value. So what is the maximum value of hx? Sorry, this function. We have already
81.
calculated here. Yeah, we have
81. Yes.
already calculated 81. So just put 81 in this. So log of 2, log of 2, log of 3, 81. Okay, now we can write 81 as what? In
9
terms of
square.
3,
9 square.
3 to the power 4.
3 to the
4.
power 4.
It would be
That would
4.
be equal to log of 2, log
4
of
of
2,
2, 4.
4. And now that would be equal to log of 2, uh, what? Okay,
2 to
so
the
2
one
2
concept
power
But
here, here
2.
also
2
one
will be the
concept.
answer. One
Log of
answer.
a is 1, right?
Yes, sir. 1 is the answer.
And log of a to the power x4. Suppose it is like written like this. So how can we can write 4 log
log
of
A.
a. So this concept here, this concept. is used.
Sir, suppose if there is one term with log value between base value between 0 and 1, then how will approach? Then graph will not be like this.
Okay, no, no, no. Then the graph will like this. Okay. So now
Yes.
whenever the value of x is increasing, your graph is going towards negative
Minus
side.
infinity.
So it is for a less than a between 0 and 1. Okay, same graph. This is the same graph log of a log to the base ax. If the base is between 0 and 1, then the graph will be like this. Okay, and this
Sir,
is
then also we'll put the 81 and then only do
yeah,
the
yeah, yeah.
experiment.
Yes, yes. No, no. If it is like that, then you have to put something else. Means you have to find the maximum value, right? So
Yes.
now you have to put the minimum value of this. But here, this question can't be framed because the minimum value of this function is infinity. We can't find the minimum value. Have you seen the graph of this x square? If a is negative, the minimum value is we can find the maximum value only here. Remember, right? If a is negative, we can find the maximum value, not minimum value. Minimum value will be
Even
minus
yes,
infinity.
even we will get 2 points in.
Yeah.
Okay, sir.
Okay. So that won't be
Sir,
framed, but yeah. Mhm.
how do you solve a last step?
Which
I
one?
can't understand.
Which
Last
one?
step.
Last. Okay. Here. This part.
Yes, sir.
So we got the maximum value of this, right? We want to find the maximum value of hx. So the maximum value of hx will be what? Hx is from the function hx. You can see that the hx is completely dependent on x of this function, not x on this function. So
Yes,
we know
sir.
the maximum value of this function is 81. So we have just directly put it at 81 and we will got the value. And now from 81, we can write 81 as 3 to the power 4.
Yes, sir.
So we have taken 4 outside and log, you already know that log base a is 1. So we have used that concept, that's for identity and that formula. So now we will got this. So we have 4. So log base to 4 that we can write. We can write
2
4
to
as
the power
to the power 2.
2.
Now 2 will come outside log of 2, 2 that is equal to 1. So 1 is the answer. Maximum value of hx is 1. Okay,
Yes, sir.
clear? Okay, let's move on to the next
Sir,
problem.
are this PYQ, sir?
Yeah, it's just P by Q. It's last year problem. I don't know from where, but I got this somewhere. Okay, clear, right? Anybody having doubt in this? Okay.
Hi, I just joined the meet actually. One more doubt actually I have in general. For this quiz 2, is it for week 1 to 8 or just 5 to 8?
It's 5 to 8, but some of the concept we're gonna use means it is mathematics, right? You have seen that
Yeah, yeah.
in this problem also.
So
This
it
is
will be
from
carry forward,
PYQ.
but majority it
Yeah,
will be
yeah.
from 5 to 8.
Yes.
Okay.
Majority
Okay.
portion will be five,
So
5 to 8.
will week 9 be included this week's?
No. Week nine
Oh,
is not in.
thank you.
Week nine is for end term. Okay. So see this problem. Find the domain of the inverse function. Uh, what will be the domain of this inverse function? So okay, inverse of that function. So first of all, we have to find the inverse. So what is the inverse of that function? How to find inverse? You have to write. So
We
here in
will
this function,
solve.
yeah,
We will calculate for x,
yeah. For
and
here,
we will
this
just
function.
change the variable then next.
Okay. So let me tell you about the inverse function. So for this function, suppose this function is defined from R to what is the range of this function? R to some range. Okay. The range of this function will be the domain of the inverse function. Okay. First of all, learn this. The range of this function, whatever the range will be, range of this function will be the range of this function will be the domain of the inverse function. And how to calculate the inverse expression means whatever the inverse function you can calculate. Here this function is written in terms of x, right? Why in terms of x? So now you have to write x in terms of y. For that, what I will do, I will write like this: x square x cube minus 1. Now, put this minus 1 to left hand side. Y minus 1 is equal to x cube. And x equal to, now from here we will get as x equal to y minus 1. Now, what will be the f inverse of
It
x?
is
F
y plus
inverse
1,
of
right?
x.
Y plus 1 equal to x cube.
Okay, yes, yes, sorry. Y plus 1. Okay, y plus 1 to the power 1 by 3. Or we can also write it as like this: y plus 1 to the power 1 by 3. And now find the domain of this function. So is this function is restricted to any values? So you know that this function is not restricted, right? It is, you can put any value here, positive, negative, whatever the value. So the domain of this function will be,
Real number.
R.
R.
Or
here I should write x because I have changed the
Yes,
expression.
yes. F inverse y is equals to x plus 1
Hmm.
whole cube.
Why I have written x? Because I have used in the place of x, I have written f inverse of x. Now I can write like this. So this is the inverse function. So the domain of inverse function will be what? All the real numbers.
or
And in the question also, I have told you the domain of this function. So the range of this function will be the domain of this function. Let's find the domain of this function. You know how the expression, what the how the graph of a x cube will look like this, right? This is the graph of x cube. If you are adding or subtracting one, will they change the graph? No, it will not make any effect, right? Whenever x equal to 0, y is equal to minus 1. So it will just move like this. So it will be same as like this, same graph. This is the graph of x cube minus
Sir,
1.
can you please repeat the domain section along?
So there is one trick, means this is the proper way to find the domain of an inverse function. But yeah, there is one trick, that the domain, the whatever the range of this function, whatever the range of this function, if they are asking, it will be the domain of the inverse of that function. Okay, means uh, range of fx is equal to domain of f inverse of x. Sorry, f inverse x. I should write like this. Okay, so there is one way to calculate the domain. You can easily calculate by this way, and there is another way. Just find the range of that function. So you can get it if you put any value. So first of all, to find the range of this function, what is the domain of this function? Domain of this function will be R simply, right? You can to put any value. The function is defined on the real line. And what will be the range of this function? If the domain is R, range is also, because we will get positive value, negative value, greater than 0, less than 0, right? 0 also in x equal to what? X equal to 1. So the range of this function is also R. So the function is defined from, so the function is, what is the range of this function? Domain is R and the range is also R.
R.
So which is equal to the domain of the inverse of that function. So we have already calculated the domain of inverse of that function. So
Sir,
the
can
first
you
step
tell
is,
this concept of graph shifting downwards and sidewards? I'll
okay.
confuse.
So I have added, okay. So if you add in a graph, if you add minus one, the graph will move. If you add some constant or subtract some constant, it will move on the y-axis. Okay. If you
Okay.
move on y-axis, or there is one simple way. This is point 0 comma 0, right? From there way, that's where I got the graph. This is point 0 comma 0. So if you put x equal to 0, what will be the value of the graph? X
Minus.
equal to 0, value will be minus 1. So this graph should also pass 0 comma minus 1. So just I have drawn the same graph, just I shifted it to 0 comma minus 1. It is not passing through 0 comma 0. It is, instead of that, it is passing from 0 comma minus. That's it.
Okay, sir.
Sir, one small doubt. Root over minus 3 is a real number or a complex number?
Yeah, it's a real number.
Okay.
Sir, how we will calculate the domain of x plus 1 whole cube root? Is there any particular method?
No. Domain, you have to put the values. See, for what value this equation will satisfy. Suppose instead of this, if it is written like this, x plus 1 to the power 2, then you already know that it is not defined, right? X plus 1 should be, then domain will restrict it to x plus 1 should be greater than or equal to 0.
0.
Yes, but here we have an x cube. So x cube, it's defined on real number. Why this is restricted? First of all, why this is restricted? Have you seen the graph? This is the graph.
Yes, sir. Understood.
And so it is only on the positive side of y, right? So here the range is only positive. That's why it is restricted to only positive side. The domain of this one will be the x one. The range of this is only positive side. That's why the domain of this inverse of function inverse of x square is only on the positive side. But here for x square, in the case of x square, the domain and the range is also from R to R. So there will be no restriction in domain and range. Okay,
Okay,
got
sir.
it? It is similar to y equal to fx, y equal to x, y equal to x. It is similar to like that. Okay, so let's move ahead to the next problem. So this is the problem. Which of the following statement is true about this function? So first of all, we know about modulus function. So first of all, let's learn about modulus function. Fx equal to mod x. So what are the properties of the modulus function? Have you seen the graph of the modulus function? And there are two concepts of the modulus function. It will give only positive value, right? This modulus function will only return positive values. So when it will, how it will giving positive value? So if you are taking any value, so this is the definition of the modulus function. If you are taking x which is greater than or equal to 0, this will give x, or it is minus x if you are taking x less than or less than 0. Okay, this is the definition of the function. So let's check with some examples. So add fx equal to minus 2. So you have put in x equal to minus 2. Then which of the following function will invoke? This one will gonna invoke. So minus of minus 2, that is equal to plus 2. This is same as modulus function. I have break this modulus function into 0 and in between 0. Okay, in the between two functions. So this is the definition of the modulus function. Okay, and the graph of modulus function is also look like this. So can you tell me what will be the minimum value of that modulus function? Minimum
0.
value. Yeah, minimum value will be 0. Okay, this is the minimum value we got of fx equal to mod x. So let's solve the problem. Clear? This concept is clear, right? For all? Yes, no.
Yes, sir.
Yes, sir.
Clear.
Okay. So let's move ahead. So which of the following statement is true about the function? This is the function we have. Uh, so f is defined from all the natural number. Is it true? You can put any natural number. True or false? Tell me. This function is defined for all the natural number. X belongs to all the natural number.
Yes, sir.
Yes, it is.
True.
But we can put also
True.
negative values, right?
Yes, sir.
Yeah, it is. You can put also negative numbers. Okay.
Yeah, we can take real.
Okay. So and then tell me f is bijective or not. For bijectivity, there are two concepts. It should be 1 1, that is injective.
And on 2.
No, not 1 1.
For bijective, it is
It
1
is
1.
not.
Okay,
It's not.
it is on
Modulus
2.
function is not on one.
That is surjective. And you already know that the modulus function is not 1 1. Let's take with the help of example. Put x equal to 3 and x equal to 1, or I should put x equal to 1. Yes, x equal to 3 and 1. You will get 0 in both the case. That means this function is not 1 1, right? So now the concept of injectivity and bijectivity also used. Okay, so this is not 1 1. So the this option is incorrect. What about the range of this function?
Range is 17 to infinity.
Range is from
17 to infinity.
okay.
Correct.
Range is from 17 to infinity.
Yeah, minimum value will be 17.
Yeah, the minimum value will be
How to
17 because
calculate that? How
Minimum
to
value will be
calculate
17
this?
only.
so for to calculate this, first of all, you have to find the minimum value, right? It you know that the modulus function, we have the modulus function, and it should be so if it is written like fx equal to mod x, so what will be the range? Range when this value will become zero. Range when this value will become zero. And let's check when it this overall function will become zero. Okay, overall function will become zero or whatever the okay we want to calculate the range. So to calculate the range, this part is always positive, right? This part will be always positive. Okay, to calculate the range, you have to use the different concept. You know that this part is always positive because of modulus function. This part will always positive. So what will be the minimum positive real number? Minimum positive number or non-negative. This part is also always non-negative. You can write positive. I should not write
How
Zero.
to
positive. I
calculate
should.
range?
Yeah,
Zero, sir.
that's I'm telling you. No? This overall this part is always non-negative. That means the minimum value of this will be
Zero.
0. Okay. And then if you are adding explicitly something, that will be the minimum value. That will be the minimum value of that function. So the
What,
minimum
sir?
value of that, if you are adding a constant in positive in a 0, if you are adding some constant, then what will be the value? Minimum value will be minimum value of fx is 17, right?
Yes, sir.
Yes, sir.
So the value of fx will be okay. So minimum value of this will be
Sir, but here if
0.
we put x0 and if we remove that 17, we are getting
Huh.
3 na sir. 3 is
No,
minimum.
no, 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 no. How you can remove 17?
No,
How you
if
can?
we only see for mod,
Yeah,
only see for
on
mod and put x0, then we are getting 3.
no, you are not getting 3. Okay, 3 is greater or 0 is greater?
3.
3 is greater. So to find the range, we have to go from the minimum to maximum, right?
Yes, sir.
So you don't need to find the greater value, you need to find the minimum value. So that's why I'm saying that the okay. First of all, let me give you the example of this. See here, this function we have got the what is the range of this function, this mod function?
0 to
First of all,
0
infinity.
let's
to
see.
infinity.
Range will be 0 to infinity. How you got 0 to infinity?
By graph.
By graph also, and you can also see that this value is always non-negative.
Yes, sir.
If I add something in this, I have something suppose as c, some constant number. So what will be the minimum value of this function, or what will be the graph?
It will be shifted by that constant.
Yeah, it will be shifted by that constant in x-axis, right? In sorry,
Yes, sir.
y-axis. In
Y.
y-axis. So the minimum value will change from 0 to c. Okay, whatever the constant you are adding. If it is positive or negative, we don't care. But yeah, whatever the constant you are adding, it will be from 0 to infinity. If I add plus 1 here, it will be going to towards from here to infinity. 1 to infinity. Okay. So that's where we got the range of that function. Similarly, like that, you have seen that this is a modulus function. We know that the minimum value of this modulus function is 0. And if we are adding something 17, so then overall, what will be the overall minimum value of that function?
17.
17.
17, right? So
Yes,
from
sir.
here we got as 17. Then what will be the range of that function? Is
17 to
from
17 to
infinity.
infinity.
17
17
to
to infinity.
infinity.
17
So
to infinity.
here it is given that range is from 0
Sir,
to
but
infinity.
constant will
That is
go into
infinite.
y-axis only, no, sir.
No, no, constant it why it is on y-axis
Sir, but
means
here inside our mod, there is a quadratic, na sir. We should also see for that also.
okay. So If you are saying quadratic function, yeah, we have the quadratic function. So put any value and you will get some negative value. Are you able to get some negative value? No, right?
No, sir.
So what is the root of this quadratic function?
1
What
and
are the
3.
roots of 1 and 3, right? So if you put 1, if you put 3, you will get 0, right? These two values. So maybe that will be clear for you, but where your guys are confused, just tell me now.
So range will be 0 to 17.
How it will be 0 to 17? Okay, the range of the function they are asking, not the range of this, range of the function they are asking. Fx equal to this. I have given you the example. If I added one c here, we have changed our range from 0 c to infinity. Similarly, like that, here if I add 17 here, they have added 17 here. So you will get okay. At what value this fx is equal to 0? Can you tell me? Okay, let's say suppose you saying that range from 0 to infinity. I am taking that fx equal to 0. Now let me solve it. Okay, that way you can get it.
It will be
X
what?
square minus 4x plus 3 plus 17 is equal to 0. Clear? Till then it's clear.
Yes.
Someone has asked, it's clear for you. Till then we can write like this. It is
Yes, sir.
fx is equal to 0. You are saying that 0 is the minimum value. Okay. So fx is equal to 0. Now can we write x square minus 4x plus 7 3 is equal to minus 17? And is it possible to get the negative value of modulus? Is it possible this value will equal to minus 17?
No, sir.
Not possible. It will always
Not
give
possible.
positive value.
It will always give a positive value. That's why the minimum value will be 0. Okay, minimum value of this function will be 0. So here we can write the range. To find the range, the minimum value will be 0 plus 17 to infinity. Okay, that is equal to 17 to infinity. Are you getting it? Or maybe you can draw the graph on Desmos
Got it, sir.
and you can visualize it also.
Sir, but last time you said that the constant value goes under the y-axis.
Yeah, it is going towards y-axis. Suppose let's draw the graph of that function, whatever the function you have. Maybe I'm not drawing the exact. I said that it is the minimum value. Okay, if I added 17, so it will be going towards upward or downwards. It will going towards upward, right? So this will be the minimum value. It is somewhere 17 to infinity. Okay, same function. It is from 0 to 17. Last time I have told you to make this mod 0, to make this mod 0 because 0 is the minimum value. That's why I said that if you made it to 0, you will get 17. Okay,
Okay, sir.
maybe it's clear for all. Okay, first in the definition of the function is defined on all the x belongs to R. The function is defined on all the real numbers. Okay, this function is defined on all the real numbers. That is also incorrect. Only they are asking only because of only it is incorrect. Okay.
Sir,
Uh,
sir, if this question didn't have a constant like 17, then the range would be
then
from 0 to infinity, right, sir?
yes, correct. If the constant doesn't have, if this function doesn't have any constant plus or minus after that, the range will be from 0 to infinity. Clear, right? Shall we move ahead?
Yes, sir.
Yes, sir.
Okay. Let's solve this problem. M log 3. So m log 3. So this is the problem we have. Okay, this is from logarithm. Okay. Now the logarithm starts. So you know the properties of logarithm. All of you know the properties of logarithm. Okay, let me write log of
Sir, please
a.
show that question.
Okay, this one.
Sir, can you please zoom it?
Okay, Okay. Let me introduce some properties of logarithm here. Okay. Log of A, log of B is equal to log of A into B. A by B. Okay, and the third property will be log of A x to the power m is equal to m log of A x. Or there is one more, 3, 4. Log of 1 by n m is equal to minus log of m n. Uh, okay, sorry, nm. And you have used the change base rule. If you remember the change base rule, log of AB, if you don't know, you can take a common base as 10, log of B, log of 10, base 10, A. This is the change base rule. So remember this one, this is very important. Or remember this too. And also this one. And also one more, log of A is equal to 1. Okay, this would be enough to solve that problem. Okay, let's solve this. So this problem says that
Sir, open your previous slide.
previous slide, which one? This one.
Log rule.
Okay, the properties.
Yes, sir.
Hmm.
In
Okay, sir.
last property, we can also write ln b by ln a also, right?
Which one?
At sixth property, right? That ln b log a to the
Uh-huh.
base a.
You can take any common base, any base. You
Okay.
can write log of
And
any,
also,
introduce any another base.
Okay.
I don't know the value of x. X may be just greater than or not equal to 1. Okay, I will write the values. X should be x should be between 0 and okay. X belongs to 0 to infinity except 1. Except 1. Okay. So let's solve this problem. So this problem says that okay. So here you can see this question. This question is completely here. We have the same base, right? 3, 3. The base is same. So what we can do? Okay, let's think about these functions. M log 3, 2. Okay. Let's think about this function. What we can do with this function? So can we? Is it? Okay. Let's try to write this function in some more way. So I will tell you that these two functions are equal to log of 3m. These two functions are equal. Are you agreeing with that or not?
Yes.
So for that, to prove this, take log 3 both side. Take log 3 both side. It will equal to log of 3m and this power will come outside. Or I should write like this, otherwise you will get confused. M2 log of 3 to log of 3m. So we can write log of 3 2 into log of 3m is equal to log of 3m log of 3 2. See, these two functions are equal. If these two functions are equal, can we write 2 with this any function? Suppose it as m log of 3 2 is equal to 8. I have just written, I have added this. I have written if these two are equal, I have written only on this. I have just added these two functions. Now can we write like this? and can we divide it by 4? It will give divided by 2 and we will get 4. Now, what is the next step to solve
Sir,
this?
how come 2 came there?
Okay,
Sir, how come 8?
so 8 is from the equation. Okay, you got it right. These two functions are equal. Can we make it equal to t if these two functions are equal? Okay, now otherwise you can also do if x and y are equal, if x and y are equal and x plus y is equal to 8, if it is written like this, then what we can write? 2x is equal to 8. Can we write?
Yes, sir.
I have put an x in the terms of y. If you're not getting is x plus x is equal to 8, 2x is equal to 8. Can we write like this? Is it correct? Fine for you guys?
Yes, sir.
Okay. So m log of 2, sorry, log of 3 2 is equal to 8. 2 into, I am writing y because I have taken m as x. Okay, m as x.
Sir,
And
I
x
didn't
is equal to
understand
y.
2m.
Sorry.
Sir, I didn't understand that 2m
If
log.
Sir, can you please repeat again, sir?
from where you got it? I'm confused. Tell me first. You agree with this point or not? M log 3 2 is equal to 2 to the power log of 3 base
Yes, sir.
log of m base 3. Are you agree with this or not? So can we write this?
Sir, I don't understand that structure because in answer there is 8 numbers. Then when taking that side, we will put 8 plus meter.
Your voice is not audible. Miss. Some background voice is coming from your side.
Sure, when there is an 8 in the RHS, so when we take from LHS to RHS, then we should add that 8 to
I am not adding anything. I am not adding anything. If these two functions are equal, see here. If these two functions are equal, then we can write this times into this. Okay, I am explaining this. So if these two are equal, I am writing this this in terms of this. Is it correct or not? This line is correct or not? First of all, tell me. Are you able to understand this line or not?
Yes, sir.
Okay. So from where I will add this to. Now
No, sir,
this will
how that
become
m log came?
where m log
Sir, in third line.
in this third line. I have taken log base in this. I have taken log to the base 3 both side, right? I have taken log to the base 3 both side. So from there, this power will come in multiply,
Third line.
and then this one will become this one. I have to come out this line.
Yes, sir.
These two both are equal. So can we write this in terms of this? Here we have this question, right? This is our question. If you see, are you able to see this question? So I am writing this in terms of, in the place of this, I am writing m log 3 2. See here, if these two
We
are
can
equal.
write both. We can write both. 2 into m to
We
the
can
power
also,
log 3 to. We can also write 2 into 2 to the power log that function also two times because those both functions are equal. We have proved
if the,
here.
we have already proved here, right? This both functions are equal. That's why we have written like this.
Yes.
Okay, let's move ahead. So 2 into 2, sorry, m log 3 2 is equal to 8. Now from here, I am dividing 2, it is coming out to be 4. Now log of 3 2 m to the power log of 3 2 is equal to 4. Now take log to the base 3 both sides. Log to the base 2 will be helpful, right? This would take
We can
We need
use
to.
the property here. We can just
Yeah, yeah,
write
you can
as 2
directly
to the
use.
power log.
Hmm. Okay. Mm, okay, take log to the base to both sides. Take log to the base to both sides. This we will write. I am taking log to the base to both sides. Okay, m is equal to uh,
Uh,
log of 3 to log of 2m is equal to log of 2 4. Correct or not? Tell me.
yes.
Yes, sir.
Now we can do what we can do. Change the base rule. You remember. So just change it to 10. Change base rule. Just make it easy. Change base is to 10. We can write log. I'm changing using the change base rule. Log of m log of 2 is equal to that is equal to 2. Okay, because log of 2 to 4 is where this is coming from. See here, 2 will come outside and log of a is 1. So now we can cancel out this. This is in the numerator and this is in the denominator. So we can cancel this term, right? We can cancel this term. Now what happens? Log of 3m is equal to 2. We can
So
write
how 2 came?
again how 2 came where 2. I
Log
have told you
log base 2 4. That yes,
from here 2 is coming, right?
yes.
Now this will be equal to we know what is the definition of log. Log of ax is equal to y. That means x is equal to a to the power y, right? I am using this here. This is all actually the definition of the log. So here m is equal to 3 to the power 2, that is equal to 9. Okay, now the value of m is 9. It is little bit tricky, but if you see the recording, you will get it. Watch it once again. M is equal to 9 is the correct answer. Okay,
Yes, sir.
let's move on to the next question. Okay, this is again the properties of the logarithm function.
Sir,
I have shown you the.
I'm sorry, sir. I have a doubt.
Okay, yeah, go ahead.
Sir, we have taken 2 to the power log of 3 raised to log 3m and equated equal to like 2 raised to 2. So we could have equated the powers also, right?
Yes, yes, yes. You can equate power also.
Okay,
So
thank you,
to
sir.
check the answer is correct, we can put
Sorry.
m. So to check the answer is equal to 8, we can put m to 9 and calculate and see.
If you know the answer, you can also calculate. But here they are asking the value of m. How you can put directly 9?
Yes, sir, we got the value of m is 9.
Okay, so you want to see that if M9 is satisfying or not.
Yes, sir.
Okay, so I am putting here 9. So this will equal to 9 2 to the power log 3 2 plus 2 log 3 9 is equal to 8. Now we know that this what we can do from here. This will be a constant. We can use like this log to the base 3 2 is equal to what will be the value of this? This will give 2, right? Overall, this will give 2 and 2 to the power 2 is 4. So 4 will 8 minus 4. And due to the lack of spaces, I am using some shortcuts. So this will give uh, now this will equal to 9. Now take log to the base what? To both side. Log to the base again both side. So we have this log to the base 2 9 into log to the base 3 2 is equal to log to the base 2 4. This is giving again 2, and this power will again cancel out, log to the base 3 9. This is equal to 2. 2 is equal to 2. Satisfying the equation. Okay, it is satisfying the equation. Clear? Hmm. See, I have written lots of things, so maybe due to this, it might not be visible. Okay, just let's solve this problem. So this question says that now this is on the base. Now we are changing the base and we will draw the graph. First of all, let's draw the graph of the logarithm function. If a is greater than 0, if a is greater than 0, or let's write changes to b, because they have given on b, so b will be fine here. So if b is greater than 0, this will be the graph, and if b is between, if b is between 0 and 1, this will be the graph. This is symmetrical graph. Okay, this is like that. Hmm. Okay, if b is between 1, and this is the graph of log bx. This is on the x-axis. So let's see. So B, the question, the option says that which of the following options are correct? If B is between 0 and 1 and X is also between 0 and 1, then what will be the value? Log of B, X is negative. So let's see if B is between, okay, let's also coordinate this point. It is 0 and this value is 1. So if B is between 0 and 1, that means this graph, right? This graph, and the value of X is between what? 0 and 1 means this. What will be the graph? So log of bx is negative. Is it giving the negative values? No, right? It's giving positive values. It is giving positive values. See here, this graph, this area is giving positive value, right? So this option is incorrect. Okay,
Sir, will you draw the diagram again? Because it's not clear.
I have drawn the diagram. Are you able to see the diagram? Is my screen is visible to you guys?
Yeah, it's visible,
Yes.
but it's not clear.
So can you please explain again,
Yes,
sir?
clear.
I don't get it.
Or sir, you can graph that in the Desmos and just copy and paste it here. It will be better if.
Sir, what is that B less than theta? Sir, your voice is not audible.
Sir, you are explaining. You are muted.
Okay, now am I audible? Am I
What
audible
does the
now?
theta means? That
Where is
b less
theta?
than. It's not. I don't know that what is called. B is greater than.
B is greater than 1. This is the graph.
Okay, it's one. Okay.
And if B is between 0 and 1, this is the graph. There is no theta. Okay, now let's find out. So this is the graph we have, and now the options are given. These are the options. So the question says that B is between 0 and 1. So this is the graph B is between 0 and 1. This will be the graph. B is between 0 and 1, and the value of x is between 0 and 1. So this is the graph, and it gives the positive value, right? This is in the positive side of the x-axis. So it says that it is negative. No, it is positive. Okay, so this option is incorrect. It is positive. Same question in the another expression they have given that if b is between 0 and 1 and x is also between 0 and 1, and if x is greater than b, x is greater than b, then the log b x is greater than 1. It's correct or not? Let's have an example and we can solve it. So let's take b as 0.2 and x as 0.4. So let's find out. Log to the base 0.2 log to the base 0.4. What will be the value? Sorry,
ரெண்டு ரெண்டு தனியா வந்திருக்கு. ரெண்டு ரெண்டு தனியா வந்திருக்கு.
0.4. Can you mute if you are not speaking? Please mute. Okay. So now this is equal to what? We don't know the value first of all. So we can use the log. You have in exam you have the calculator. So change it into base 10 and you will get the value. Use this method to find. In exam, use the calculator. Calculator will be given to you. So let's find the value of. Now, can anybody tell me what is the value of 0.4 log? Log 0.4 minus
Sorry.
0.399, and what
Yes,
will be
sir.
the value of 0.2 minus
Minus
0.
9.
So this will be negative, negative will cancel out, will give positive. It is coming out to be at least half, half. Let's suppose it as half. So that is greater than half is greater than 1. Is it greater than 1?
No,
No,
sir,
right?
not really.
No.
So this is also incorrect. What about this? Now check for this. So now b is between 0 and 1, and the value of x is also uh, is it correct or not? X is greater than 0, x is between 0, the value of y is greater than x, value of y is greater than x. So check this option. Let's take bx as what? Tell me any value. X as 1, suppose x as 1 and y as 2. So log of 0 and 1, what will be the value of x as 1? It will give 0, and x as 2 will be here, and this will give a negative value, right? So which one is greater? This one is greater, right? So this says that x is okay, this will give this, and it will give y is greater. This one is greater. So this option is correct or not? Take any value, suppose it as 0.5, or maybe let's take value 0.2. We have found it out the value 0.2, right? So 0.21, this is for x and this is for y, 2. So it is giving 0 and it is giving what? So use again log 2 upon log 2 upon log 0.2. Log 2 is
minus
0.3 and minus
0.
0.6669. It is negative, right? So that means this option is, it is coming out to be something negative.
That
So that
option is
means
correct, right? 0 greater than negative.
maybe we have chosen the wrong
So answer is
option.
minus 0.42.
Yeah, option is correct. Okay, this option is correct. Okay, because we are getting negative value here. If you see here, it is coming out to be minus 0.3 upon 0.69. Suppose it is a 0.6, it is 1 by 2. Minus 0.5 something, close to. Okay, so this option is also correct. This option is correct. What about this? We can easily get it, right? Log of 10, 100, 10 to the power 2, that is equal to 2. And it is a rational number? Yeah, it is a rational number. That is also correct. This is also correct.
How to calculate that?
Which one?
Log 100.
Just use the calculator, put log 100, you will get 2.
So no need to put log 10 and then 100.
Log 10 is already default, right? So in your calculator, I will tell one thing. If it is written log, so in any question, if it is written only log, that means here the base is only 10. If it is written, if they have written log to the base, they will written ln. Okay, and this is base 10 x. This is equal to log x. Only simple. They will not mention the base if they are using 10. Okay, but in
Sir,
your
can you
calculator also.
sir can you revise the question fastly?
So this question says that you have to find the different. Uh, you can watch the recording. Means I have to solve many problems are there. See, if you are strict with one problem, it's only 1 hour. So maybe you can watch the recording. Okay, if you are not getting it, just watch 1 or 2 times. And somebody has asked me about what is the value of log 10 100. This question, right? So let me explain it once again. It is log 10 10 to the power 2. So I'm taking 2 outside. It will give 2 log 10 10. We know log a is 1, 2 into 1, that is equal to 2. Let's move ahead to the next problems. So yeah, in this problem you have to find f of g of x. So first calculate it, what is the f of a g of x and at which point this function will be discontinuous in its domain. So let's check. Let's find f of x. f of x. So f of fx is equal to 1 upon x plus 1, x minus 1, that is equal to 1 upon x minus 1 minus 1. This is equal to what? X minus 1 upon 1 minus x minus 1, x minus 1 upon 2 minus x. This is the values. And check the discontinuous points. So what is the domain of this function? First of all, let's find the domain of f of x. Domain will be all the real number and domain of this function will be what?
R minus 2.
X belongs to all the real number except 1 and 2. 1 and 2. Why we have excluded 1? Because fx is not defined in 1. We have to think about fx also, right? So fx is not defined in 1. If you put 1 as a domain, so here this fx is not defined. That's why we can't find f of x. So that's why you have to exclude 1 and 2. So this function is continuous in all the points and except 1 and 2.
So in composite functions, we should see the domain of the main
Yeah.
function and the sub function, right, sir?
Yes. 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 If you want to find the domain of the composite function, you have to check the main function and the whatever you are putting. Suppose in the place of here in the fx they have gx, so you have to exclude all the points where gx is not defined from the domain of f of g of x. Okay, if you want to find f of g of x, so you have to exclude all the points where the gx is not defined from the domain of f of g of x. Clear?
Yes, sir.
Excel.
So this one will be the homework. Solve. I am solving one. This is the same question. So one will be the homework. So let's solve it. What will be the number of solution 9x plus 3x minus 3? So how to solve it?
So
Anybody
we
having
could
idea?
consider 3 power x as some kind of variable like y.
Yes. Yes. Suppose it as y. Let it as y. Then it will become 3 to the power x whole square plus 3x minus 6 is equal to 0. Y square plus y minus 6 is equal to 0. Now y square plus 3x minus 2x is plus 6, sorry, minus 6. Y plus 3, y minus 2 is equal to 0. Y equal to 3 and, sorry, minus 3 and 2. Now check which of the following are the possible values. So 3 to the power x is equal to minus 3. This is 1. And 3 to the power x is equal to what? 2.
2.
So this is possible or not? This is not possible, right? Suppose if you want to, okay, let's check if it is possible or not. Take log to the base 3 both side. 3x is equal to log of 3 minus 3. Okay, it fails, right? Log 3 minus is not possible. Log value here, log of ax, x should be always positive. X should be always greater than 0, right? The value of x should be always greater than 0. So it is not possible. So this one is not possible. See the second one, log 3, 3x, log 3, 2. Yeah, this is possible. X is equal to log. Okay, let me write it outside. So from here, the value of x is coming out to x equal to log 3, 2. So number of solution is only 1. Answer is 1. Okay, got it clear? Similarly, you can solve this function. This one. This one will be your homework. I'll solve it.
Sir,
Okay, let's move on.
I have solved that other question. I have got the roots as 0, 1 and 2. So 0 is not possible. E power of x equal to 0 is not possible. So the answer is 2, right? For the other question. You gave homework. You are on mute, sir.
Sorry. E to the power x should not be equal to 0. It tends
Yeah.
to 0, but it should not be equal to 0.
Okay. Then the answer will be 2, right? 1 and 2
Yes,
are
yes.
the other roots. Okay.
If you are getting 3 options and if you are getting 0, then answer will be 2.
Okay.
Correct.
Thank you.
Okay, let's solve this problem. This is you have to find the evaluation of the limit. So let's evaluate this function. This function says that limit x tends to 2 x to the power 6 minus 4x minus 16 upon x cube plus 2x minus 12. If you put x equal to 2, what you will get? Let's check. For to find the limit, first of all, directly put the value. If you are getting indefinite, if you are getting indefinite form, then you have to use the L'Hopital rule, right? So what are the indefinite form? 0 by 0, infinity by infinity. If you are getting this type of expression, 0 into infinity, 1 to the power infinity. Oh, sorry, 1 to the power 0. So there are total 7 indefinite form that I have told you in one of the session, and you can also check it out. But maybe these two are the important. If you are dating these two type of expression, you should use L'Hopital rule. Okay.
Yes, sir.
So solve this. X to the power 6. So just put it value x equal to 2. You will get 2 to the power 6. What is 2 to the power 6? Well, anyone? 2, 4,
64.
8,
64.
64 minus 48 minus 16 and 8 plus 4 minus 12. So see here we are getting 0 by 0
0
form.
by 0 form.
So what is the next step? You have to use
L'Hopital.
L'Hopital rule, or you can also use here factorization. Factorization will be tough. Yeah, factorization will be tough because here x to the power 6, if it is simple type of expression, we can use the factorization, but L'Hopital will be famous premier. So what is L'Hospital rule? Anyone tell L'Hopital rule? This is not L'Hospital.
Yes,
L'Hopital.
we have to just differentiate until we don't get until the 0 by 0 infinity by infinity form is removed.
Yes, you have to differentiate the numerator and the denominator independently. Okay, so limit x tends to 2. Let's differentiate the numerator. 6x to the power 5 minus 24 and x3 x squared minus plus 2. So if you put x equal to 2, you will get it is not coming out to be 0. The numerator is not coming out to be 0, right? Now it is independent. It is not 0 by 0 form. Now you can directly put x equal to 2 in the function. You will get the answer. 6 into
12.
what? 32 minus 24 upon 3 into 4 plus 2. 12 plus 4. 12 plus 2. 14 upon what? 32 into 72 into
168.
3. What?
192 minus 24, which is 168.
168.
168, sir.
That
And the
is
answer
coming
is
out to
12.
be. Well,
12. 12.
so 12 is the answer. Okay. Okay,
Yes,
let's
sir.
move ahead. Okay. In this problem, you can see easily. Now,
Sir, can you show
this
the
is.
last one?
Mhm.
Okay, sir.
Okay. Okay, let's move ahead. So this is the problem we have. In this problem, this is another. You have to find the limit x tends to 1, or no, x tends to infinity. Limit x tends to infinity. Okay, what this question says, fx equal to this at x equal to 1. Hmm, is half.
What we have to do in this question?
Sorry, I haven't taken the screenshot of the poll question. I have missed something. Hmm, let's solve the next one. I will check for this. Hmm, okay, calculate the limit of the following function at x equal to 1. Okay, again you have to calculate the limit at x equal to 1. So how to calculate fx? What will
Again,
be
here
the
I think,
limit?
sir, we use the L hospital rule
1
because
minus 3 plus 2, 1 minus 5 plus 3 plus 1. Again 0 by 0 form, right? So you can use the L'Hopital rule and you can find out, right? Okay, so I'm leaving this question. You can try it by own. Okay, you have to find the
The
limit.
answer alone to verify.
Sorry,
Can you tell the answer alone to verify?
1.
1, okay, sir, I got it.
Okay, let's solve this problem. This
Sir,
problem
am I
says,
audible?
yeah, you are audible.
Can you tell the previous one question's answer alone so that I can
Yeah,
verify it?
answer is 1. Answer is
Okay,
1.
sir. Okay.
Okay. Solve this problem. This problem says that limit x tends to, okay, whenever this type of expression is given, this says that this expression means that limit x tends to infinity a to the power n. Sorry, n tends to infinity, not x. The variable is n. So limit n tends to infinity a n. So here we have the expression, the value of a n, limit n tends to infinity. A n is equal to 22 2022 upon 2024 plus 8 into 2023 n plus 4 into 2023 to the power n. Okay, what we have to do here? Again, if you put n tends to infinity, it is coming out to be what? Infinity by infinity form.
Infinity form.
So again, you have to use L'Hopital rule. See the L'Hopital rule, how is extensive use. Remember the L'Hopital because they will generally have. So for a constant function, the differentiation is 0,
0.
8 into n 2023 to the power n minus 1. It is 0 again. 4 into n 2023 to the
For
power n
previous answer, I
minus 1.
got 0 divided by 0.
So if you are getting 0 by 0 form, again use L'Hopital rule.
How, sir?
Again use, here I have used the L'Hopital rule, right? See here in this question also we are getting 0 by 0 form. So I have used L'Hopital rule. I have to differentiate the numerator and the denominator.
What have you done, sir?
I have to differentiate. You know how to differentiate the equation?
No, sir.
So you have to first go through the lecture, okay? You have to go through the lecture. You haven't watched anyway.
Or
So please go
or
through the
there
lecture.
are, yes, or there are, you can search it. There are the list of differentiation formulas, so you can go through that also.
Hmm.
Okay, thank you.
So answer is 2. Okay. Clear for all? It's anybody having doubt in this?
Sir,
Yes,
one
sir.
minute, sir.
Mhm.
Sir, why, sir, you added 0 divided by 0 there?
Because the differentiation of 22 is any constant function is 0. You can't get it, means because you have to you don't know the differentiation, you can't get it. Just after this is now the extensive use of differentiation. It is a revision session, not a actual session. I will not able to explain all the topics. So in just 2 hours I have to solve all the problems.
Okay, sir.
So 2 is the answer. Clear for all others?
Yes, sir.
Yes, yes.
Okay. Now this one you should solve it. Tell me the answer.
2 by 3 is answer.
Sir, is it 0?
Yeah, 0 is the answer.
Okay.
How we are getting 0? Okay, limit n tends to infinity a n 100 n square minus 11 upon 100 n is cube plus 7. So it is coming out to be 0 by sorry, infinity by infinity, right? So you can use L'Hopital rule. Otherwise, there is one more way to solve this is, remember this, limit n tends to infinity 1 by n is 0. Okay, remember this. So I will divide the whole equation because here I can't get 0 in the numerator, right? So I will divide the whole equation whatever the highest power we have. So here the highest power is n cube. I will divide the numerator and the denominator with n cube. So 100 upon n cube, 100 n square, minus 11 upon n cube. Here 100 upon 100 n cube upon n cube plus 7 upon n cube. Limit n tends to infinity. So here it is coming out to be 100 upon n minus 11 upon n cube upon 100
100 plus 7
minus
by n cube.
limit and tends to infinity. So what will be the value we will get? If limit n tends to infinity, 1 by n
This
tends to
becomes 1
infinity,
by n. So 1 by
0
infinity.
infinity, this will also become infinity. It will become 0 by 100. That is equal to 0. Okay, it's clear?
Nice.
Or you can use L'Hopital rule. L'Hopital rule says another way. So here also you can see this problem we can also solve it by that way. But here the x tends to 1, so we can't do. But if it says that n tends to infinity, what is the this? So you have to divide the highest power. So always remember, and we will give you a trick. If this type of problem with the same exponential, and if they are asking that limit n tends to infinity, just write the coefficient of the highest power will be the answer. Suppose here, if it is same question, limit n tends to infinity, if written like this, x to the power 5, 2 into x to the power 5 plus whatever we have, and 5 into x to the power 5 plus something we have. So what will be the answer? 2 by 5.
2 by 5.
Yes. Okay, the coefficient will be the answer. Because we have used this n tends to infinity, we have divided it with the highest power and then we have used this. So yeah. Okay, now this problem says, so this expression is quite a little bit sequence and series. There is a use of sequence and series. So this question says that limit n tends to infinity. Okay, let me tell you one thing. 1 plus 2 square plus 3 square dot upon n square. What is the value? N into n plus 1, 2n
2n
plus
plus
1,
1 by 6.
6. Remember this. So we're gonna use this. I will take the 6 common and 1 plus 2 square, 3 square plus dot n square. We have root under 4 n to the power 6 plus 5. Now 6 into use this n into n plus 1, 2n plus 1 by 6 upon this root under 4 n to the power 6 plus 5. This 6 will cancel out. Now write a little bit. Okay, let's solve it. N square plus n 2n plus 1 root under 4 n to the power 6 plus 5. 2 n cube, and then we have things with n cube only because the here what is the highest power in the lower side in the denominator numerator? What is the highest power?
N to the power 6.
No,
3, 3.
Huh?
6 by
3
it
only.
2.
is
Okay, okay.
root under 4 n to the power 6 plus 5. This is n to the power 3 is the highest, right?
Yes, yes.
Let me solve it by way and then I will show you the trick. N square 3n square plus 1 plus n.
Root we can write 1 by 2, so it will cancel out to
Sir,
n
Yeah,
power 3.
the
Yes.
whole power, the whole numerator and denominator, we can divide it by n to the power 3. So if you divide
sir,
n to the power
I
3,
didn't understand how you got that numerator, sir. Can you please explain it again?
it is a summation, it's a formula. It is a formula, okay.
Okay,
1
sir.
square plus 2 square, sum of the sum of the square of the natural number.
Sir, 1 is the answer.
No, 1 is not the answer. So divided by n cube, you have the highest power, right? Now limit n tends to infinity. So I have told you divided with the highest power. So in the numerator is also 3 and the denominator is also 3. So let's divide it. We will get uh, 2 plus 3 by n plus n upon. Oh, is it visible? Otherwise, just tell me.
Yes, sir, visible.
Okay. It will be black, white, and gray. So I should here write in gray. 2 plus 3 upon n plus 1 upon n square upon what? Here it would be 4 upon n to the power 6, n to the power 6 plus 5 upon n to the power 6. Why it will become? If you divide it by n square, then in the root it will become n to the power 6, right? If you divide it by n cube, in the root it will become n to the power 6. So n to the power 6, n to the power 6, n to the power 6 will cancel out. Here in the numerator we have limit n tends to infinity. Use this limit n tends to infinity. This part will become 0, this will become 0, this will become 0. So it will be 2 upon root under 4. Okay, someone said 1. 1 is correct, sorry. 2 upon 2 is 1. Okay, clear? And there is one more trick. The trick is what? From here I can easily solve it. From here I can get okay. From here I can get it that we have the power. I have told you the power. So just use this. Here we have 4 and sorry 4 root 4 upon root 2. Sorry 2. So this will be the coefficient of the highest power. Root 4 upon root 2 upon sorry 2 upon root 2 root 4 2 upon root 4. I have written the coefficient only and that will be equal to this. Okay, clear? Shall we move on to the next
Sir,
problem?
answer can be -1 also, right? Root 4 is
No,
-2 and 2. Both can be
no, no, no.
the.
Mhm. If it is minus root 4, then it is minus 2.
Root 4, roots are -2 and 2, right? -2 into -2 is also 4, right?
Okay, you are saying like this way. But answer is 1 only because
Okay, okay.
you can take the positive one, right?
No, it will not come -2. It only comes when it's assigned to some value like x equal to root
Yeah.
4, it will come as -2 and 2.
Hmm.
But if it's only root 4, it will only open up the positive one.
So positive one.
Okay.
Okay, now we have jumped to the differentiability part. So yeah, we have so differentiability. What is differentiability? So this is the definition of differentiability, right? This is already the definition of differentiability. So let's solve it. So we have to find the value of root under 5 into in the place of limit n tends to x tends to 2. In the place of fx, you can directly put that function. I'm directly putting that function f of 2 upon x minus 2. So if you put x equal to 2, it is coming out to be what? Okay, first of all, let's find the value of f of 2. F of 2 is what? 2 square is 4, root under 9 minus 4 is
Root 5,
5,
sir.
root 5. So we can write here root 5. Okay, if you put x equal to 2, you will get 0 by 0 form, right? You will get 0 by 0 form. Now, so that what you have to do, you have to use L'Hopital rule. So you know how to differentiate the root under function. 1 upon 2 root under 9 minus x square. What is the differentiation of 9 minus x square? Minus 2x, right? I have differentiate this and with the differentiation of 1 where limit n tends to x tends to 2. Now this will be equal to what? 2 2 will cancel out minus x upon root under 9 minus x square limit x tends to 2. Put x equal to 2 minus 2 upon root 5 is the answer.
Sir, can you please tell the
Cancel root 5
differentiating
and
part
minus 2 is
again,
the
sir?
answer.
Okay, yeah. I have missed. I have just calculated here. We have to multiply with this. Okay, let me remove this. Now we have to put it in this way. The answer will be root 5 into minus 2 upon root 5. Root 5 will cancel out. This will write minus 2 is the answer. Okay, someone is asking anything. Tell me. Hello. Anyone is asking doubt? Clear, right?
Sir,
All.
can you please explain the differentiating part again, sir? The top numerator.
Okay. So first of all, tell me what is the differentiation of root x,
1 by 2 root
Minus
x.
1 by.
right? This part is clear.
Yes, sir.
So if I write, okay, differentiation of root under 2x, tell me.
1 by 2 root x
2 root
into
2x
2x
into
into 2.
differentiation of 2x,
2x, which is 2,
which is equal to 2 upon 2 root 2x,
which will
so we
cancel
will
out,
cancel
and
out
1 by 2 root x. 1 by root
1 by 2
2x.
root will be this. So now they are asking that the differentiation of root under 9 minus x square. So first of all, the differentiation of 9 minus x square is what? 1 by 2
1
root
by
under
2, 9
hmm,
minus x square.
Sir, is this meeting live
and
streamed on
then
YouTube?
no
It is being recorded.
dx, right?
Yes, sir.
And then 1 by 2 root under 9 minus x square. Uh, Now what is differentiation of this is 2x. This differentiation of this constant is 0, minus x square is 2x. 2 will cancel out, minus x upon root under 9 minus x square. That I have written minus 2 minus x upon root under 9 minus x square. Limit x tends to 2. Okay, clear?
Yes, sir.
Hmm. Yes, go ahead.
Sir, is
We
this
can continue.
meeting being live streamed on YouTube?
No. It's been recorded and you will get the link. So yeah,
Okay, okay, sir.
this question, now let's calculate the left hand limit and the right hand limit. So you know how to calculate left hand limit? Left hand limit, that is LHL. So if someone asks you to find a limit at some value that is x equal to 1, suppose it x equal to 1, what will be the left hand limit? You have to take the number which is less than 1 and put it in x. Or there is another way we can write limit h tends to 0 f of 1 minus h, because I have removed some value. And what is right hand limit? RHL limit x tends to 1 plus f of x. Limit h tends to 0 f of 1 plus h. Okay, here the h tends to. Got it? How to calculate left hand limit, right hand limit? So this question says that this is the function we have. We have to check the limit of that function at x equal to 0. See, is the statement true? the left hand limit and the right hand limit of the given function exist at x equal to 2. So here the function is defined, the definition of the function. At x is less than 2, this is the function. If x is greater than 2, this is the function. This one is the greatest integer function. This one is the fractional part. Fractional part means this is the fractional part. Anybody have doubt in greatest integer fractional part? Fractional part function, greatest integer function. Anyone having doubt in this type of functions? No, right? Okay, let's solve it. So let's calculate left hand limit LHL. Limit h tends to 0 f of 0 minus h. So I will put in the place of, I will take the number which is less than 0. So this function will invoke, this function will gonna invoke. So over here we have to write 0 in the place of h, 0 minus h plus 1, the greatest integer of 1 minus h. What is the greatest integer of 1 minus h? Where h is tends to 0. Okay, h is here tends to 0, that means h is something which is less than, it has something but it is close to 0.00001. So if you removing one value 0.0001, what will be the greatest integer of this? 0, right? So the greatest integer will be 0. So I should write here 0. What is RHL? Right hand limit. Right hand limit is limit h tends to 0 f of 0 plus h. So the right hand limit will be the fractional part. Now the fractional part will invoke because this function is defined when x is greater than 0. This is fractional part. We have adding something, the number which is close to 0. So x plus 1 limit h tends to 0. In the place of x, I have to write 0 plus h. 0 plus h. Now this will equal to what? I'm writing here. This will equal to fractional part of 1 plus h limit h tends to 0. So if you are adding any integer in a fractional part, that will not change the function. So the answer, the value will be limit h tends to 0 h, right? H is close to 0, so this is also giving 0. So see here, LHL is equal to RHL and it is also equal to the function value. So we can say that LHL is equal to RHL, that is equal to 0, and the functional value at x equal to 0 is also 0. So this function is continuous. Okay, this is a continuous function. Okay, clear? So this statement is true. Here this statement is true. This function is continuous. What about this? What are the total number of points at which the function is not continuous? So the function, you can see that the greatest integer is not continuous. If you remember, the greatest integer is not continuous the at which points? Tell me. At integer only, because if it is suppose if you are taking number, what will be the value of the greatest? Let me give you an example. 1.00001. What will be the greatest integer of this? Is 1, right?
One.
And if you are taking number which is 0.999, 0.1234, what is the greatest integer of this? 0. But
Zero.
is there any difference? There is very slight difference in between, right? So the greatest integer is not continuous. This is our right hand limit and this is our left hand limit, LHL. So greatest integer is not continuous at integers. But here we have seen that at x equal to 0, the function is changing. Because of that, this function is continuous. And then let me draw the graph of that function. See how I can draw the graph. We can also draw the graph of that function. So at integer, we have to check 1 minus 3 minus 2 minus 1 0 1 2 3 and check the function from okay, what is the definition? Fractional part. So how the fractional part will look like? Fractional part will look like this. Whole here, whole here. Okay, and the greatest integer will look like this. Let me draw with different color. This will be the greatest integer at x equal to 1, and then it will be this will be the graph of the function. Okay, so see how many discontinuous points are there between 0, minus 3 and 0. So this is one discontinuity point. This is one, two, three, four, five. Five discontinuous point between
Still, how
minus
many
3
sums
and
are
0.
there?
Sorry,
Still, how many sums are there?
how many
Sums are there.
sums?
Total questions she is asking.
Okay, questions are is around. Now the tough will question will come. So it has one, two, three, four. Four questions.
Okay, sir.
Okay, so this has
Class
total
will be
five.
posted in the YouTube.
No, I will share the link. So there are total number of five discontinuous points. Okay, you have seen that there are total 5 points at which the function is discontinuous between minus 3 and 3. Clear?
Sir, how can you say that at integers this function is discontinuous?
Okay, tell me what check the left hand limit and the right hand limit at integers.
Sir, I don't get the question.
For the function and to be discontinuous, how you can identify the function is discontinuous?
If the graph breaks at a point,
Okay, in a in graphical way, but in a theoretical way.
when function tends to infinity,
No, no, no. The function, if the left hand limit and the right hand limit is not equal, then the function is discontinuous, right?
yes, sir.
So check the left hand limit and the right hand limit in every integers point.
Um, Abhishek, can you show the graph?
Yes.
So one more step has to be there, right? Or it is correct?
No, no,
Because
no.
x equal to less than or equal to 3.
Less than or equal to 3. Yeah, correct.
Mm-hmm.
See here, what this question says.
Total 6
When
points, right?
when x equal to minus 3, it is minus 3. Okay. Yeah, it is a solid point. Sorry, it is a solid point.
That is why it is showing why you should not include the function when it's starting.
It is a solid point. It is a solid point. It is a open point. Okay, it is a open point. There are two open points. So okay, just a second. Okay, let's check with this. At x equal to minus 3, the left hand limit is 3. Sorry, left hand limit we don't need to find, right? Because the left hand it starts from 3. So if the function at 3, at minus 3, at 2, at the right hand limit is also 3. Okay, so the discontinuity points are this 1, 2, 3, 4, and 5. Okay, because here it is open. Yeah, discontinuity points are this. Okay.
We
I
cannot
think
include
you
-3.
We have included -3. Let's check the
uh,
discontinuity at -3. Left hand limit no need to find, right? Because left hand limit don't exist here. Because the function is starts from 3. So we can't find. So the function value at 3 at
Okay.
-3, let's check. So what is the function value at -3? It is the greatest integer. So greatest integer -3 plus 1, that is equal to -2. What is RHL, left hand limit? Limit h tends to 0, f of -3 plus h. So that is equal to what? Greatest integer of -3 plus h plus 1. Limit h tends to 0. -2 plus h. What is the greatest integer? H tends to 0. If you take any smallest value, it will give -2 only. So see,
-2.
the function value at -3 is equal to RHL. That means the function is continuous at -3. Okay, the function is continuous at -3. At -2, we will check at -2, the left hand limit is equal to -2, but the right hand limit is -1. Okay, so we will check at x equal to -2. LHL is -2, but RHL is -1. This value is -2, this value is -1, this value is 0. Okay, the RHL is -1. So LHL is not equal to RHL. That means the limit doesn't exist at that at x equal to 2. At x equal to 1, -1, again you will check. The LHL is equal to -1, but RHL is 0. So the limit doesn't exist. At this fractional part also, whenever you go to an integer, it will give 0. Whenever you go to an integer, it will give 0. See the fractional part. Suppose, what is the fractional part? If it's 3.2, so that is 0.2, right? 0.2. If it is minus 0.3 is, what are the fractional part? 0.3 is the fractional part. Not going the minus thing. It is only defined in the positive side. So let's take 5 point, no 5, 2.9. 2.9. It is giving fractional part is 0.9. But whenever you reaches to 3, it is giving what? 0. Fractional part is 3.0 is 0. At integer, it is giving 0. It is going like a this, increasing with this between, let's see here, between 0 and 1, it is increasing. Between 0 and 1, it is decreasing. Whenever it reaches to an integer, it jump to 0. Again, it is increasing. Whenever it reaches to an integer, it is jump to 0. See here. Okay, clear? Yes, no?
so in that +3, the function is discontinuous, saying, right?
Yeah. In positive 3, let's check. We have to define the function value at 3. So fractional part of 3 is what? 0, right? But the fractional part of 2.99999 is what? It tends to 0.99999, which is tends to that is not equal, right? Okay, can I go?
Okay. Okay. Because you said when it's function start value, we should not we should not check that the value that is continue or continue.
Mhm.
If it is starting point of the function or ending point, we should not check that
No, it's different.
function
Means
or
you have to,
discontinuous.
that's not means it is the function is defined on this. See here at
Uh,
-3 to the. So you have to see about the definition. You're going to move with the definition. Okay.
okay.
Okay. Let's move on. So this is a problem we have. This is easy problem, right? Yeah, differentiability, you can solve it by differentiability, or you can also solve it by tangent. So f be a differentiable function at x equal to 3, the tangent to the line of the curve of the following function f at point 0 comma 3 passes through the point 0 comma 2. So there is a line which is passing through point, the tangent line 0 comma 3 and 5 comma 4. So find the slope of this f dash of s as x equal to 3. So if it is a line, it is a tangent line, right? It is a tangent line. It is passing through the point. So you can directly find the slope of that function. Okay. Or maybe you can use that way, the proper way. Uh, f of 3 is 0, f of 5 is 4. So you have to find f dash of what? F dash of 3. So for that you can write a tangent expression of tangent. But here simply we can find the slope, that is 4 minus 0, 5 minus 3, 2 is the answer. Okay.
Sir, can you please show the question, sir? Okay, sir.
So is the statement is true, correct or false? It is a linear approximation. Question on the linear approximation. Lx is fx is equal to x e to the power x minus 1. The point at a such that f of a is L of a. Okay. Then the find the slope. Then f of a is L of a. Then the find the slope of the curve. F of a is this f dash of a. Okay. Then so okay, what is f of a first of all? A e to the power a minus 1, right? What is f dash of x? F dash of x is what? E to the power x minus x e to the power x. F dash of a is e to the power a minus a e to the power a, right?
It is plus, right? E power of x plus
Oh, sorry,
x
sorry,
into e
sorry,
power of
sorry,
x.
sorry. Yeah, plus, plus. So, then find the L of x. L of x is what? F dash of a x minus a plus f of a. This is the formula for linear approximation.
Yes, sir.
So Lx is equal to f dash of a is what? E to the power a plus a e to the power a x minus a plus f of a is a to the power a minus 1. See here in the question itself, they have written like this. They have taken x as common. Okay, they are trying to write in terms of x. So we can also do e to the power a plus a to the power a into x minus of e to the power a plus just a calculation you have to. So you have to a to the power a minus 1. So here take e to the power a common, a plus 1 x minus a to the power a plus a square e to the power a plus a e to the power a minus 1. This term will cancel out. Here it is a quite calculation. So okay, it is minus because it is multiplied with this. So minus 1. So this statement is true. True, true. Okay,
Yes, sir.
maybe we have two questions left. So yeah, a function is continuous at a particular point then it is differentiable at that point. It is correct or false. So you have to choose the number of incorrect option. So this is statement is false, right? That means this is correct. If it function is continuous at that point, it may be differentiable at that point. But if the function is differentiable at that point, it is continuous at that point. Okay.
Yes, sir.
Clear for all? A function is differentiable at a particular point, then it is must be continuous. Yeah, this is correct statement. That means you have to choose the incorrect option. So it is incorrect. Fx and gx are the bijective function, then f of g of x is also a bijective function. It is true, right? Fx and dx is 1 1 and on 2, then g of f of x and f of g of x both are 1 1 and on 2. Okay.
Abhishek, check. Okay, it's incorrect option, right?
Uh, no,
Okay.
it is correct. Okay, sorry, it is incorrect, but sorry, statement is correct, but you have to choose the incorrect option, so it is wrong.
Okay. Then first is the correct answer.
First is the correct. Also, let me tell you the statement is false.
Correct. Okay. Okay.
False. Here the statement is true.
Okay.
Statement is true. Here the last option, fx and gx are 1 1 function. Then f of g of x is
Yeah,
also 1 1.
that statement also true.
Uh, is there any counter? Yeah, that statement is also true. Okay. So let's move ahead to the next one. This is the last problem we have from the graph. So yeah, there is it is option B, C, and D. So choose there is at least 2 points in between -4 and 4. Okay, the graph is not visible. So it between -4 and 4 in the curve where the derivatives of the function corresponding to the curve one is equal. Correct, right? Because there are many points between -4 and 4. See here the derivative is 0. See here the derivative is same. So we can say this and this. So derivative is 0. So this statement is correct. Okay. At origin, the derivative of the function corresponding to the curve 2 doesn't exist. Yeah, because it has sharp edge. Doesn't say. So derivative doesn't exist. Differentiation doesn't exist. So it is also correct. The derivative of the function corresponding to the curve 3 at origin at point -2 comma 0 is equal. Derivative of the function at curve 3 and corresponding to the point -2 comma 0. So let's take -2 comma 0 here. What is the derivative? So derivative is nothing, just a slope, right? So
0.
this has slope is this and this has slope. Here the slope is 0. But here the slope is non-zero, right? The slope is non-zero.
Yes, sir.
So this statement is incorrect. The derivative of the function exists corresponding to the curve 4 doesn't exist at any point. Your derivative exists because so here this is a constant function y is equal to 2. What is the dy by dx of a constant function?
0.
0.
0. So derivative exists. So this statement is also incorrect. Okay, that's all. Thank you guys. If you have any doubt, maybe you can go ahead. You don't go sick.
Sir, can you send me more PV questions or PDF?
Okay, I will share you a document. Go through. There are quiz to PYQ. Go to the section and So these are the links for the PYQs. Okay. First of all, B means the concept. You have to means good in concepts.
Abhishek, it is asking access, request access.
Okay, you don't have IDM mail ID, right? Mm. So there is another application. Use this application. You have to choose. You have to whenever it's come. There is a practice quiz to choose the practice quiz to, and select the course that is MLM. Okay, let me share
Sir, I
share the
asked
screen.
PY questions.
Yeah, I have given the PYQ.
No, sir, it's a link of live section.
Yeah, but it is the link of it is PYQ only, right? Okay, it's restricted to IIT man. Actually, it is restricted. So use this app, web app, quiz practice slash space. See this one. Let me open this. So use this. Okay, anybody having any questions regarding quizzes? So just be with the concepts. Just go through the revise all the concept and watch the
Chat.
revision session by instructor. Okay, that would be helpful.
Uh, like how I can get this recording and this
We will
PDF?
share you from where you get the link.
I got the link from WhatsApp.
So you will get the link same from there only. We will share it.
Okay, and yesterday also unfortunately I haven't attended that CT session, so I want that recording and that PDFs also. How I can get?
You haven't get it yet.
No, I haven't get it.
Okay, let me share it. Mm,
Sir, I'm not able to see PY questions.
okay. Elango, is there any link to share which can access without IATM ID?
No, sir, I log in with the ITM
So you
login
should
ID.
able to access the document. See this
I went
document.
inside, sir, but they have only given diploma PYQs, not for foundation.
So there are many PYQs. You have a whole sheet
So please
of
open and show
PYQs.
in your screen itself.
Okay, just a second. So are you able to see this? So here, whenever you go through, so it is written here diploma, but it has foundations also. Okay, it is written in diploma. You will check. We will open this. It will redirect to a direct to a folder which contains lots of PYQs.
Sir, please go into that folder.
Okay. So whenever you click this, it will redirect to a folder. We'll share the folder again. Just a second. Which 2DS. So is it visible? There are many PYQs. So you can see there is a section for IITM Foundation. So just click on this and go through the. There are lots of pages is coming. So go through the maths page. So maybe it is on 26 or 28. 25, yes, 25. No, it is not on 25. After CT or after English. After English, it is maths. So just scroll with the, you have to little do some hard work for to find the PVQs.
Can you share this drive link, sir, which you opened? I want this drive link.
Are you able to access it with, you have IITM mail ID?
No, it is my personal mail ID.
Do you have IITM mail ID? So this, see this, who is asking PYQ? See, this is maths 1, sem 1, maths 1. So see, the PYQs are there. Okay, see, now the stats PYQs of stats. Okay.
Otherwise, one share that drive link, Abhishek. Like I will check I have access or not.
Okay. I will share the Google Sheet also. Here is the Google Sheet. That's all, guys, for today. So we have lined up with the stats also. Those who having stats too. I guess you don't have. So the stats to live session is also, revision session is also we gonna happen. Thank you all. Bye.
Okay, bye.